So today what we will do, we'll take some characteristics and some more interesting aspects about sound we will get to study. एक एक करके देखेंगे. We are almost reaching the mid part of the chapter. So let's talk about three aspects of sound in which we say the three aspects that we study are these things you have actually covered in grade 8. One is loudness. Okay, these are very important concepts for you in order to answer 1-mark questions. They will give these questions. You won't expect any definitions out here, but there will be only 1 mark like assertion, reasoning हो सकता है, true or false हो सकता है. तो चीजों को समझेंगे. सबसे पहला है loudness. What is loudness? Now listen to me very clearly. Okay, we say that the amplitude is a measure of loudness. Okay, the amplitude. Because at your level you don't have formulas and all. Okay, so one of the factor that controls loudness is amplitude. Amplitude is an indicator of loudness. ठीक है बच्चा, आराम से समझिए इस चीज को. Amplitude is an indicator of loudness means जितना amplitude ज्यादा होगा loudness भी ज्यादा होता है. अब loudness, we have got another definition or another meaning of loudness, because that meaning comes into role when we talk about intensity. Amplitude is also going to talk about another parameter called intensity. Now question is, does that mean, sir, that intensity and loudness are same thing? No, there is a thin line difference between intensity and loudness. Two sounds of the same intensity may not be of the same loudness. Okay, I'm contradicting myself, but you need to understand. Two sounds of the same intensity may not be of the same loudness. Loudness को अगर आप और अच्छी तरह से समझने की कोशिश करेंगे तो loudness is the response of the ear to a sound. आप समझ रहे हैं? अभी मैं यहां पे नवरात्रि का डांडिया बजाना शुरू कर देता हूं. लाउड है, बिल्कुल लाउड है. ये साउंड की इंटेंसिटी में, उतने ही इंटेंसिटी में हमारे बाजू वाले सोसाइटी में एक और साउंड बजाना शुरू कर देता हूं. सेम इंटेंसिटी. इज दैट आर बोथ द साउंड्स ऑफ सेम इंटेंसिटी? यस. बट यू आर सिटिंग हियर, आपको कौन सा साउंड लाउड ज्यादा लगेगा? ये वाला. लाउडनेस इज योर ear's response to a particular sound. That means two sounds of the same intensity may not be of same loudness for you. Loudness for me may not be loudness for her. When I was your age, and like I used to play cassettes for sort of rock music and all, my dad used to come, and if I hear my dad is coming, I used to switch it off, because he will say, ये सब ताम झाम क्या बजा रहे हो, so loud sound and all. और मुझे वो सब मेलोडी लगता था. It's your response. Loudness is measured in a unit called dB. dB कैसा होता है? D means deci. Bell बहुत बड़ा unit होता है. dB means like centimeter. This is decibel. So anything like over 80 decibels is considered to be loud. ठीक है? Loud हो जाता है, 80 decibel से loud हो जाता है. तो ये इसका meaning आपने समझा है. Amplitude means more. Now question arises: two dandiya musics at the same volume, played at the same point. Two different music systems, and you are sitting here. If you are finding one of them loud, you should find the other one also loud. Two music systems played, एकदम एक ही जगह पे बजा रहे हो आप, and you are able to distinguish the sound between two, same volume, और आप वहां दूर, थोड़ी दूर में बैठे हो. आपको अगर ये loud लग रहा है ना, तो आपको ये भी loud लगना ही चाहिए, because both the sounds are of same intensity and you are the same distance from. So there's a thin line difference. Whereas we say, if anybody tells you what gives you a measure of loudness, the amplitude gives me a measure of loudness. So in fact, if we make a diagram and we try to show it like this, let's say there is a sound which is represented by this wave, and there is another sound which is represented by this wave. इसमें हम क्या बोलेंगे? This is say sound 1, and say this is the white one is sound 2. We will say sound 1 is louder than sound 2. because it has higher amplitude, but frequency is same. देखो एक ही टाइम पे दोनों जीरो पे आते हैं, एक ही टाइम पे दोनों फिर हाफ साइकिल। वो तो if you take this as the let's say if I take this, okay, this point, कौन सा point, ये वाला point पकड़ लेते हैं, this point, then don't you think the time taken for one cycle is same? So frequency should be same. Have you understood? Clear? Loudness आई, हाँ बोलिए बोलिए।
Loudness also depends on the distance from which.
Not distance exactly. It is distance is not the right word because I say जितना हम शोर के पास जाते हैं हमें शोर बर्दाश्त नहीं होता है, एक्चुअल वो डिस्टेंस नहीं है। ऐसा ही अगर होता तो पब में जाके अब यो ब्रो एकदम टिक 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 चल रहा है, वो तो आपको लाउड। इट्स योर रिस्पॉन्स। अगर यही मैं दाड़ 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 हैमरिंग करता रहूं आपको लाउड लगना शुरू हो जाता है। इट्स योर रिस्पॉन्स ऑफ द ईयर। आपका ईयर कब बोल देता है ये लाउड है मुझे। लाउडनेस एक तरह का फील है बेटा, फील मैथमेटिकली। आगे क्लासेस में जब आप मैथमेटिकल कैलकुलेशन करोगे ना तो हम इंटेंसिटी की बात करेंगे थोड़े और आपको इजी करके बताता हूं। कोई खाना जब आप खाते हैं, मान लीजिए यू आर हैविंग छोले भटूरे, कैन यू क्लासिफाई हाउ मच ऑफ कार्बोहाइड्रेट इज देयर? यस। हाउ मच ऑफ फैट इज देयर? यस। अगर मैं बोलूं ये स्वादिष्ट है कि नहीं, टेस्टी है कि नहीं, ये समथिंग सब्जेक्टिव है। इट इज योर रिस्पॉन्स ऑफ योर टंग टू दैट फूड। कोई मैथमेटिकल फॉर्मूला से मैं स्वाद नहीं बता सकता हूं। लाउडनेस वैसी चीज है। माई ईयर्स रिस्पॉन्स। इंटेंसिटी इज उसका फॉर्मूला बनता है। इंटेंसिटी इज डायरेक्टली रिलेटेड टू एंड loudness is also related to amplitude. So when a question comes and somebody tells you, is loudness and intensity same? No, they are not same. While intensity also depends upon the amplitude and loudness also depends. Loudness is my response to the, it's like taste versus calorie value of a food. Dairy milk का calorie value मैं बता सकता हूँ, पर taste में नहीं बता सकता हूँ। मुझे अच्छा लगता है, आपको अच्छा नहीं लगता है। बात समझ में आई? Clear? डायग्राम ऐसा आएगा अगर किसी ने आपको दिया। क्या हो गया, सब लोग बड़े सोए सोए से मायूस मायूस हो। ठीक, चलिए अगले पैरामीटर को पढ़ते हैं। मिटाओ इसको। चलिए अगला पैरामीटर देखते हैं। एंड आवर नेक्स्ट पैरामीटर वुड बी, आवर नेक्स्ट पैरामीटर इज पिच। पिच जैसे वहां आपने लाउडनेस और इंटेंसिटी को पढ़ा, यहां पे वैसे ही है पिच एंड श्रिलनेस। श्रिलनेस इज अ सब्जेक्टिव टर्म, फीलिंग। पिच इज अ मेजरेबल थिंग, हम पिच को मेजर कर सकते हैं, ठीक है ना। पिच कैन बी मेजर्ड। सो पिच ऑफ अ साउंड डिपेंड्स अपॉन द फ्रीक्वेंसी ऑफ अ साउंड। फ्रीक्वेंसी के ऊपर डिपेंड करता है, और फ्रीक्वेंसी हमेशा डिपेंड करता है किसके ऊपर? सोर्स के ऊपर। फ्रीक्वेंसी और किसी चीज पे डिपेंड नहीं करता। What is a frequency? Frequency tells me how many cycles per second. So if the source is vibrating much more faster, the frequency is higher. If the source is vibrating slowly, the frequency is less. So pitch is a parameter of sound which depends upon frequency. Higher the frequency, so if you jack up frequency, the pitch is also set to jack up. Okay. If I increase frequency, pitch भी ज़्यादा हो जाता है. That's why we say that if you compare a child and an adult, a child has more frequency, pitch ज़्यादा है उसका. And if you allow a child to scream, a child can scream with much more shrillness. So pitch के साथ एक और term हम पढ़ते हैं, and this is a subjective term which is shrillness. दोनों ही frequency पे depend करता है. आइए चलिए इसको भी diagram में देखने की कोशिश करते हैं. Like say, for example, this is say my sound 1, right? And this is sound 2. My sound 2 has much more frequency. My sound 2 has much more frequency than sound 1. अच्छा, जब frequency ज़्यादा होता है ना, भले ही आपके स्कूल में ये हो ना हो, if the frequency is more, then always understand that the energy associated with the wave is also more. That's why बच्चा चीखने से दूर तक सुनाई देता है. A wailing baby's cry can be heard. The child may not be, a loud music which is played in one tower may be limited to that loud tower. It doesn't disturb you. But one child, if child wails at night, you will be able to hear the wail. बहुत दूर तक travel करता है. That's why, since again you all don't know radios, in radio we have two type of waves: medium waves, short waves. शॉर्ट वेव में क्या रहता है, फ्रीक्वेंसी हाई रहता है, the frequency is very high, so short waves can travel. You can speak from England and that. However, medium waves are limited to a particular region. For example, say AIR Hyderabad is transmitting something on medium wave. आप ज्यादा से ज्यादा उड़ीसा के बॉर्डर तक सुन सकते हो, that too based on how strong the transmitter is. Sometimes if the transmitter is strong, you can hear it to far off also. पर short wave में ऐसा नहीं है, short wave एकदम आराम से आएगा आपके पास, ठीक है? So if the frequency is more, the pitch is more. If the frequency is high, shrillness. So yeah, the pitch is equal to frequency. Pitch and frequency are same. Okay, pitch we use the word where we talk about threads. You know, screws में thread होते हैं. So here we say how many cycles per second. In screws we say how many threads per inch of the screw. So that's a term we use in threads called TPI. Bolt देना, कितने TPI का bolt? 12 TPI, 16 TPI means 1 inch में 16 threads होंगे. See, engineering and all these things are very nicely designed. People don't understand. वो तो screw लेके ऐसा tight करना शुरू कर देता है. Means if you give 13 turns, the screw advances how much? 1 inch. That's the pitch. आप पढ़ेंगे आगे screw gauge and vernier calipers जब पढ़ेंगे तो उसका. Okay, so here we also need to understand one more thing. If they at all ask us. So the human audibility range, okay? The human hearing range. The human hearing range varies from 20 hertz to 20,000 hertz. Okay, 20,000 hertz तक एक इंसान सुन सकता है. इससे आगे अगर आप आवाज की फ्रीक्वेंसी है तो you are infrasonic, and this is your sonic range. And if you are more than this, then you are ultrasonic. So rhinos can actually make infrasonic sounds. Rhinos communicate with infrasonic sound, and bats and other animals communicate with ultrasonic sounds. So nowadays, if you have called large godowns where you have perishable food particles and all, जैसे ये बड़े-बड़े departmental stores होते हैं, so they have this fear of having rodents come and attack because इतना सारा, if you go to a big bazaar, इतना सारा गेहूं रहता है, खा लेगा. So you have repellents which are ultrasonic repellents. Those machines will be kept. They are actually screaming. You can't hear. Who can hear? Rodents can hear. इसलिए वो rodent आएगा ही नहीं वहाँ पे. Ultrasonic repellents. They are available as small plug points in your houses also. लगा के रख दो, घर पे कोई rodent नहीं आएगा. पर वो actually आवाज कर रहा है. हाँ. So dogs hearing ability is much. Babies, human babies can hear below 20 hertz and beyond 20,000 hertz also. So this is the range, infrasonic, sonic, and this becomes ultrasonic. ये ज्यादातर हम क्लास 8 में बात करते हैं, ठीक है? ये हो गया. पिच के बारे में हमने जान लिया है. Nocturnal animals, they will use this. Going for further on, our next topic is known as the quality of sound. Quality. हालांकि NCERT is not speaking about this. जान के रखो. Quality of a sound is measured by a property called timbre. Okay, what does quality mean? Quality means simple thing. Same frequency, same amplitude. Okay, same frequency, same amplitude, right? इसको कुछ ऐसा है. Suppose it's same frequency and same amplitude. ऐसे. And you have, say, this is being played by instrument A and this is being played by instrument B, right? And ये आपका कान है. This is your human ear. You can readily distinguish between the two. You'll say एक गिटार का sound आ रहा है and one is coming from the saxophone. That differentiation you are doing on the basis of timbre. Timbre allows to differentiate two sounds based on their quality. Quality means not that this is inferior and this is inferior. Two sounds of the same frequency and same loudness produced by two different instruments. If your human ear can, how do we say, suppose you all are in this room and I'm in that room and this fellow utters some words. I said, Dipanshu, क्या बोल रहे हो? मैंने इसी का नाम क्यों लिया? The human eye can distinguish between, the human ear can distinguish between the sounds from two different sources. And that is due to the property of a sound called quality of sound. And the word used is timbre. Fill in the blanks आ जाता है कभी कभी 1 mark के लिए, ठीक है? कर लिया ये 3 चीज. अब आइए आगे चलते हैं थोड़ा और. Right, shall we go ahead? Okay. Now, the next topic that we will try to study is called reflection of sound. Reflection of sound. In this topic, sound will behave the same way as light behaves. That means sound also undergoes reflection, and sound will follow the same laws of reflection. What was the laws of reflection of light? That angle of incidence will be equal to angle of reflection. ठीक है, ऐसा रहता है. So reflection means what we try to understand here is that suppose you have got some barriers, okay? ऐसा आपके पास एक barrier है, and you have a sound wave, and I have a sound wave, and the sound wave is, let's say the sound wave is traveling in this direction. Sound wave हमारा ऐसे आया है, तो ये sound wave यहाँ पे hit करने के बाद again the sound wave will reflect back. Just like a ball bounces away, the sound waves also reflect back. But reflection को हम थोड़े से deep में पढ़ेंगे into 2-3 more parameters of reflection, like we'll study what is echo, what is reverberation. So this is called reflection of sound, and it obeys, what you should remember is that it obeys the same laws of reflection of light. So there is a lovely experiment which is there in your NCERT book, as well as it's there in, you can do that at your home also. Many of us use this thing called kitchen में paper tissue rolls होते हैं ना. Once the tissue roll is over, then you get that cardboard pipe inside it. Don't throw the pipe next time. Okay, what you should do is that you design a setup like this. एक setup design करते हैं कुछ इस तरह से एक setup design कीजिए. Let's say take any platform. This is your platform, and all right, and then you make some center lines बना लेते हैं, something like this. ऐसे मान लीजिए, ऐसे center line बना लेते हैं, and ऐसे एक और center line बना लीजिए. And then those cardboard shells that you had got, you take your cardboard shells and place them, okay, in this manner. Place your cardboards in this manner. You understood what I'm saying, right? These are the two rolls, empty rolls of that paper tissue roll. And after this, you can have one nice little clock out here. Take a clock. You have a clock डाल दो, right? This is your clock. And you bring your ears out here. You bring your ears out here. This is your ear. You will be able to hear, and you actually you adjust these two in such a manner that at a particular combination, first ऐसे करने से ये clock का sound थोड़ा दूर दूर करना चाहिए. You will be hearing through this very nicely. That means the sound wave is going here, hitting this surface, and it is getting reflected back. And the best at which you are able to hear, at that time they ask you, try to find out the angle of incidence, and by just drawing a normal you can find out. So you can prove that sound also follows the same laws of reflection of light. ये समझ में आया ना? So sound, so light, so in reflection of sound we say that sound behaves exactly same. Sound will behave, sound behaves just similar as light behaves, and the laws of reflection of light holds good for the laws of reflection for sound. So n number of boundaries we have, n number of reflections can happen. So let's first see some of the parameters or some of the implication of reflection of sound. Number one, the first one is known as reverberation. Reverberation. पहले इसको समझते हैं reverberation क्या है, and is it good or is it bad, or how do we control it? When you go and start changing your house and you go to a new house, or somebody has bought a new flat and you go to that flat, when you talk, don't you hear that the sound reverberates in that room? It's empty flat, there is nothing in that room, okay? It's not echo. It's not echo. It's not echo. Okay, it's not echo. The sound is actually hitting many obstructions in that room. Typically, the obstructions are what? The wall, the ceiling, and the floor. And as a result, the sound, there's a persistence of sound. In class 8, you learned about something called persistence of vision. That if an object is shown to a human being and taken away, the object remains in our vision for 1/16th of a second. Within that 1/16th, if you show another one, तभी हमें continuous दिखना शुरू हो जाता है. So reverberation is the persistence of sound due to multiple reflections until the sound ultimately dies down. The sound has to die down. These multiple reflections have to die down, but they will not die that way. One reflection, like I have spoken, if I am speaking with an intensity of this, the reflected sound intensity will be less, but by that time it is again getting reflected. So our job is reverberation helpful for us? No, reverberation is not helpful for us. They will not give us clear hearing of sound. So what do? We have to, reverberation is like we say it is the persistence of sound due to multiple reflection. And overall, as a phenomenon, this will be irritating for us. This is an irritating phenomenon. And if you love music and you have gone for some concerts or something, this is not going to help you. So what we have to do, we have to damp these sounds. We have to damp these sounds. तो reverberation को control करने के लिए हमें सबसे पहले क्या चाहिए? We need good absorbers, or you need to damp. You need good dampers. Now, what are good dampers? ऐसे घर पे सबसे पहले खाली घर पे जब you have cleaned the house, put the curtains on. जाओ वहां से खाना ले आओ, वो सब नहीं होगा. Then get your sofa, carpet. The more things which you have fluffy and cushionable, they will work as very good dampeners. So if you go to PVR and all movie halls, have you seen the boards are all cushionable boards? The backside, generally in pubs. In a pub, if you go, the pub will also have double door. The first door makes you enter a no man's land, and then you open the second door and you get inside. And if you see the walls and everything, there is a lot of paneling done. These panelings which are there, they will not have cushion materials like curtain materials or fine glass upholstery which are cushionable. They are all supposed to absorb these multiple reflections. So what does these absorbers do? Absorbers can be things like carpets, they can be panels, okay, panels which are made up of microfibers. Then you can have curtains. Then you can have dashboards, and all their job is to absorb multiple reflections and give you one sound. अच्छे गाड़ी मन में अच्छे गाड़ी और थोड़ा कॉस्टली और नॉन कॉस्टली गाड़ी में ये रहता है. A costly car will have lot of padding in and around it. That's why you don't hear the engine noise at all. Engine उतना ही noise कर रहा है, right? But you won't hear that engine noise or the tire noise that is coming up. In fact, that will also add to the quality of the music system output which you are playing. अगर आपको music सुनना है तो उस गाड़ी में music सुनने में भी अच्छा लगता है. You will see that the cushions, the dashboard of the car, the ceiling, the fenders, everything is fine. So if you go to like concert halls and all, what we do in every concert hall, you will have always arch ऐसे रहेगा. Sorry, you will have arch रहेगा पीछे. So whatever sound goes, the sound is brought to stay within, and then multiple तरह reflect नहीं करेगा, एक ही side में reflect करेगा. And then we have got our absorbers which will take care of this absorption. Then only the sound quality will be clear.
But in concert halls you need reverb.
That is a different concept. See, if you are listening to a choir or something, I am saying in a proper audio, in a show, that see, we also introduce echo chambers in our musical instruments because we need echo in something. But as a whole, reverberation is not something that I want. अभी आप डिपेंड करता है, कोई भजन सुनने गया है, कोई राग सुनने गया है, हिंदुस्तानी क्लासिकल सुनने गया, वहां थोड़ी कोई रेवर्बेशन मांगेगा. कोई कॉयर सुन रहा है, उसको वहां पे रेवर्बेशन चाहिए. You're playing a chord and you're singing, reverberation is required. Like old days, if you go to Gothic churches and all, they're having high dome, huge reverberation will happen. There, the exact clarity of the sound nobody knows. Opera में exact clarity of sound आप समझते हैं क्या? नहीं. But if you want to pick up each word clear, you can't have reverberation. Have you understood? Reverberation is the persistence of sound due to persistence. Sound रह जाता है, खत्म नहीं होता है. जैसे मैं बोलता हूं, ये आवाज खत्म होनी चाहिए ताकि आप मुझे क्लियरली सुनो. बट जब ये रूम खाली है, whatever I speak, hey, see there, what is happening, ऐसे आवाज होता है. ये echo नहीं है. This is not echo. ठीक है, समझ में आया? So we use dampers, absorbers like carpets, dashboard, flashboard, and one of the best examples are movie theaters, pubs, discos, even the car in which we travel. They're all supposed to have very good quality. In fact, what you call, when the music system which I play in my house, okay, that's from Bose. So that has got a technology called Adapt IQ. Means if you take my music system to your house immediately, suppose उठा के लेके आ गया, and you try to play, you will not get the same sound as you're getting in my house. Why? Is my house something different? No. That time when Bose launched that music system, they used to say that every house is not done with all sorts of damping. My house is not a cinema theater. It's a normal house. I've got glass on one side. I've got wooden work on one side. I've got cutlery, crockery, everything. So Adapt IQ is a software which will actually balance you are supposed to sit with that headphone on in 5 different places first and configure the system. The system will automatically configure. And based on your house, it will give you one output. Now, if you take my system to your house, the first job should be again reconfigure it. So it will again reconfigure, because in your house, you may have different type of instruments in and around you or different type of devices. Ye clear hua? So reverberation has to be taken care. In a movie theater, we can't have reverberation. Agar
Acoustics, what is that?
acoustics means sound only. Acoustic means is another word in physics. All the parameters of sound. Acoustics are all the sound parameters of the room. Acoustic has many meaning. In physics, if we say acoustics, we are talking about sound. If you say about an acoustic guitar and a lead guitar, that's a different. Acoustics is like what are the sound related specifications of the room. Acoustics means how much is the height, what is the material, what type of reflection is out there. So we say that don't make a conference room out here. The room acoustics are not good. You have got something which is a big generator beside. So that's for acoustics. ठीक है, ये clear हुआ? अब कुछ और devices देखते हैं, and then we go to echo. Okay, we see some devices now. Number one is the stethoscope. Okay, the stethoscope of that a doctor uses. That also works on reverberation. Sorry, multiple reflection of sound. So you will have a small thing like this, and you know this has got a fine membrane. Stethoscope's cost depends upon the type of membrane that you use. And the excellent stethoscopes are the ones which are used for pediatric purpose. बच्चों का जो होता है ना, और कभी भी आप next time डॉक्टर के पास जाएंगे तो आपके डॉक्टर के स्टेथोस्कोप का क्वालिटी कैसा है जानने के लिए look for this logo L. Littmann is supposed to be the best company for stethoscopes. Each stethoscopes will cost, like जो लोग मेडिकल में अच्छे रिजल्ट करते हैं, like they also buy, like when you play good badminton you will have a Li-Ling racket or something like Yonex के racket. Littmann stethoscopes go up to 30,000 35,000. और pediatric वाले बहुत costly होते हैं, because बच्चे का तो heart ही इतना सा, you know what is the size of your heart as the size of your fist. So the kiddo's heart will be this much, and when you put the stetho on his or her chest, at that time it should pick up that vibration. So what vibrates? The stethoscope's membrane vibrates. Have you all tried hearing with the stethoscope? If you want, I can get you one. I can get it to the class next time. So you put it, and on the stetho there will be a hole out here. So you're supposed to put your finger on that hole, not hold it like this. On the center point, you put your finger on that hole. And then I'm drawing it in a bigger size. So that so the tube, sometimes it will. So I'll have the tube that connects you to your ears. The sound actually undergoes multiple vibrations, and then it goes to your. This is reflection of sound. Applications of reflection of sound. Then things like the megaphone. Okay. or the trumpet and all these devices you will see there will be a conical output like this. There's a conical output. Trumpet हो गया, megaphone हो गया, जिसको लेके आप बात करते हो. So the concept is like this. You will have a concave sort of a thing, and the sound, ये आप grade 10 में light जब पढ़ोगे समझ में आएगा. Say this is the source. This is the source. If the source is almost taken to be the focus, so all the sound after reflection travel in one direction. This is the point. So in a megaphone, or say in a trumpet or in a saxophone type devices, you will always have a tubular thing ending into a conical structure. So this conical surface actually takes the shape of concave shape. और concave mirrors जब आप पढ़ेंगे नेक्स्ट क्लास में आप देखेंगे फोकस पे कोई भी चीज रहने से they become parallel. After reflection they become parallel. So that is the concept that we used in megaphone and stethoscope. Okay, now come to our most important thing, that is let's understand about echo. echo को थोड़ा अच्छा से समझते हैं क्योंकि echo के साथ आपको problems भी दे सकता है. So let's understand echo properly. What is echo? So let's say that right, ऐसा है, and see, suppose there is a wall out here. This is a wall, right? This is a wall, and you have a person standing out here. पहले echo के calculation को समझिए. What happens in echo? Echo is generated when you actually there is a time difference of 0.1 seconds between two sound. That you have to first understand. There's a time difference of 0.1 second. What does this time difference means? If this person say makes a noise, okay, if this person say makes a noise, he has made a noise, so the first sound wave travels, right? And that first sound wave, once he makes the noise, he can immediately hear it, right? Also, don't you think that the sound wave is also traveling in this direction also? As he has made a noise, the sound wave travels in this direction and again comes back here to him. This is called the echo. Echo is the rebound of the sound that comes back to the listener and is not the original one. The original sound, like I've spoken right now, I'm hearing it. Did I hear my echo? No, I did not hear my echo. Why did I not hear my echo? To hear my echo, there has to be a difference of 0.1 seconds. There has to be a difference of 0. Now this figure you have to remember, 0.1 second difference has to be there between the two sound signals. The first signal is jab maine bola hello, hello, that next one and this one should have a difference of how much? 0.1. If the sound is coming before 0.1, we will not hear echo. Have you understood? If the sound is coming before 0.1, we will not hear the echo. So let's say this is air. This is air, and the speed of sound in air is how much? Let's take it as 344 meters per second. Okay, and the sound. Try to understand very quick. Understand it very nicely. I'm not talking about the original, the first sound. I'm talking about the first echo. The first echo. The first echo originates from here, goes here, and comes back here. How much time did it take? 0.1 second. So the time taken is 0.1 second. That means what was the distance that was traveled by that echo? The distance that was traveled by that echo was 344 into 0.1, which is 34.4 meters. ये कैलकुलेशन समझ में आ रहा है? ठीक है, मैंने यहाँ पे बात किया, साथ साथ सुन लिया. Hello, hello. I'm talking about the second one, that echo. That echo sound is not what I'm hearing from my lips to my ears. From my lips, it went to the wall and is coming back from the wall and hitting my ears, as if the sound is being made by somebody else. Wait, let me finish it. That echo we can hear only when there is a time difference. The human ear can pick up an echo only when there is a time difference of 0.1 second minimum. इससे कम हो गया तो हम echo नहीं सुनेंगे. अभी हम नहीं सुन रहे हैं echo, because the sound which is coming from my mouth to my ears, and the sound is also striking this wall. Don't you agree? This wall, her head, this television, everything it is striking. None of the sound is reaching my ears beyond 0.1. They are all reaching before 0.1. तो 0.1 तो चाहिए echo आने के लिए. तो सबसे पहले हम देखना चाहते हैं that if you take 0.1, तो 0.1 is the benchmark. How much distance did the sound travel? The sound traveled 34.4. और 34.4 is जाना आना. मतलब एक तरफ का डिस्टेंस कितना है? 17.2. So this is a very dicey figure. Unless and until you are 17.2 meters away from an obstruction, there is no chance you can hear an echo. Are you understanding this part? What I'm trying to say? Echo सुनने के लिए दो साउंड के बीच में कितना फर्क होना चाहिए? 0.1 second time interval. The time interval between the two sound waves should be 0.1 second. At 0.1 second for a sound traveling through air, how much is the distance that the sound is traveling? 34.4 meters. Sound wave is traveling 34.4 meters. That means the obstruction is at what distance from me? 17.2. 17.2 से आगे अगर obstruction रहा हम echo नहीं सुन सकते. अच्छा, there's one more interesting thing. ये जो figure आप लेके चलते हो ना 34.4, so sorry 344, you're taking 344 as the speed of sound. Whose sound? Human sound, machine sound, monkey sound, barking of a dog, chirping of birds. Well, here we say irrespective of the frequency of sound. I could have used the word any sound. Why did I not use the word any sound? Because I'm into the chapter of sound. Let us be more technical. Depending on the source, the frequency varies. तोते का frequency अलग है, dog का frequency अलग है, हाथी का frequency अलग है, drill machine का frequency अलग है. So depending on the source, the frequency differs. But any frequency sound travels in air through 344 meters per second only. There is no. That means what must be changing? The wavelengths are changing. You are getting constant output as 6. 3 into 1, 6. 3 into 2, 6 देता है. 1 into 6, 6 देता है. 6 into 1 भी 6 देता है. 2 into 3 भी 6 देता है. Are you understanding what I'm trying to say? So whatever frequency sound you take, in air, sound overall travels at, this is the average speed of sound in air. And here we don't say that this is the sound of what, sir? Drill machine or human being, anything. अब echo के problems हम करेंगे. Have you understood echo? In or
Making distance 17.2 meters, right? Like is the distance increase by time period? Can you say the distance increase, or is it the constant?
which one?
The distance 17.2.
17.2 is the distance. If the time period increases, the distance increases further. इसको बढ़ाने से ये product बढ़ेगा. और दूर इससे पहले रहेगा तो echo नहीं होगा. Sometimes also we can calculate first echo, second echo, third echo. Are you understanding what we are saying? The first echo, please understand, this goes and comes back. The second echo sound also creates another echo. Hello, 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 and slowly dies down. कभी कभी आपको थर्ड echo भी कैलकुलेट करने दे सकता है. जस्ट CBSE में नहीं देते, लेकिन ICC they do. First echo, second echo. Every echo time interval is how much? 0.1, 0.1, 0.1. It's not that. Did you get it? What I'm trying to say? The first noise sound is created when I speak. 0.1 after that another sound is created. उससे 0.1 another will be created. But slowly the reflection and intensity dies down. So the echo will be like hello, 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 hello. Will die down. So एक echo नहीं होगा, 3-4 echoes होंगे एक साथ में. Reverberation is the persistence of sound due to reflection. रूम में बात 2 आदमी 3 आदमी बात कर रहा है जैसा लग रहा है. Echo is different. इसलिए तो बोलता हूँ सुनिए चीज को पहले से. Reverberation is persistence of sound. Sound का रह जाना. I have spoken, you feel as if 5 Jaideep Dases are speaking together in an empty room. You have to feel it. Echo is something different. Echo is you speak, there is silence, and then you hear another one. Due to multiple reflection and multiple, there's sometimes like thunder. Thunders जो हम सुनते हैं, thunder में भी echoes रहता है. बहुत दूर दूर से आ रहा है, एक दो जगह लग के आ रहा है. Reverberation is like sometimes you see, the classical example is when this firing goes on in and around. You hear echo, you hear reverberation also. Reverberation में एक शॉट को 2 शॉट 3 शॉट एक साथ निकल रहा है जैसे आपको लगेगा. Echo is 1 शॉट, 2 बार साउंड, 3 बार साउंड ऐसे आएगा. Reverberation is multiple reflection. As a result, the sound is still persisting. The sound has not died. If I speak, my words have to be crystal clear, and sometimes the volume has to be 0 for you to hear it. Clarity आ रहा है, ये multiple reverberation में वही होता है रूम के अंदर. Echo वो नहीं है. ठीक है, echo के कुछ प्रॉब्लम्स करते हैं, थोड़ा सा टाइम है तो देख लेते हैं. Let's see. आओ. Anything left that we have not done? Dashboard, soundboard, yes. Stethoscope, megaphone, horn. Horn is also. So a horn is what? Tell me, if you have a horn, should you have more of amplitude or more of frequency?
Amplitude.
सिर्फ frequency. Frequency.
Frequency ज़्यादा होना चाहिए कि loud होना चाहिए horn? फ्रीक्वेंसी होने से हॉर्न दूर तक ट्रैवल करेगा. क्या आप दूर तक ट्रैवल करवाना चाहते हैं? लाउड होना चाहिए. हॉर्न शुड बी लाउड. इसे अलर्ट है ना आपके लिए. In higher classes, you'll study one more thing called Doppler effect. Doppler effect is very interesting, like an ambulance. An ambulance comes with the same siren. What is that? Wow, 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 wow. But how are you able to say ambulance आपके घर के पास आ गया है अभी? That is Doppler effect. The sound will come as if it is creating a wailing sound. Ambulance आपके पास कैसे आता है? Wow, 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 wow. Like a police escort goes. Are they having variable signal? No, they don't have variable signal. But you feel a variable signal traveling together. No, they have a consistent wailing signal. And that wailing signal is traveling. So आपको कैसा लगता है कि you can close your eyes and say, हाँ अभी गुजर रही है. The squadron is passing by. ये सब अभी निकाल दिया है. इन हायर क्लासेस वी डू देम. चलिए प्रॉब्लम करते हैं ऑन एको. कोई प्रॉब्लम ही नहीं है यहाँ. सीबीएसई बोर है. ओके. Echo के concept को उठाता है sonar. Now sonar is also not there in your what you call syllabus, but we can do sonar problems. You know, right? Ships have got sonar, and they will always send those sonar waves to pick up whether there is a submarine below or not. Okay, and that's why a submarine should never make any noise. Submarine आवाज कर ही नहीं सकता है. Submarine's outlet, that water outlet, is also designed, and the most critical parts are the turbine blades of submarine. Submarine का जो turbine blades है ना, बिना शोर किए हुए जाना चाहिए. If a submarine makes a noise, that means you have given your signature. And आराम से तुमको मारेगा आके. ठीक है? A submarine is not supposed to create any noise. So let's do one problem and try and understand whether we have understood the concept of echo or not. Okay, let's say. So it says a sonar station. There is a sonar station and it picks up a return signal after 3 seconds. So the time taken is 3 seconds. Picks up a sonar station. So let's try to identify let's try to make a diagram and try and see. Suppose this is my sonar station and this is a sonar station and it is releasing a lot of sound waves. So it has released the sound wave at t equal to 0. And it is picking up it picks up the reflection after what? T equal to 3. Did you understand? Sonar has picked up. Means यहाँ पे कोई तो object है जिसको hit करके ये आया है. Like ocean depth and all analysis, oceanography में यही तो use होता है. How do you understand that tightening is right below or not? Okay. So it has picked up after 3 seconds. And this is all happening in water. The entire thing is happening in water. So definitely we cannot use the speed of sound. We will use the speed of sound in water, which is around 1550 meters per second. The speed of sound in water is 1550 meters per second. How far away is the object? How far away is the object? Socho. It's a very simple problem. All you have to calculate is what is the distance traveled by the sound wave.
Sir, it's 1550 to 3.
1550 into 3.
4650.
4650 is the total distance traveled. 4650 यानी कि आपका कितना होगा 2325 meters away. 4650 means the object is how much? 2325 meters away. Clear हुआ? समझ में आया ये? Very easy. This is the total distance traveled by the sound wave is what? Sound wave started from here, again came back here. How much time it took? 3 seconds. How much distance it covered? 4650. So how far away is the object? So have you understood echo?
Yes.
In order to understand echo, you might be getting short answer type questions. Always remember to observe an echo or to clearly distinguish between an echo and the original sound. The time difference should be how much? 0.1 seconds. Now you did this problem on water, but generally we say at air, the speed of sound is taken to be roughly is how much? 344 meters per second. So total distance traveled is how much? 34.4 meters. That means the object should be at 17.2 meters away. 17.2 meters is the nearest distance of the object, the minimum distance of the object for us to clearly receive an echo. Okay, two more things, and on our next topic we will go is applications of like ultrasound and other concepts like sound and light. Who is faster? Light is faster than sound. That's why whenever the thunder strikes,
Yes.
you see the lightning first and then you hear the thunderstorm, right? Obviously if you are far away from a Diwali cracker bursting site and you are in your balcony and you see the rockets going up, then you always see that the rocket has burst first and then you hear tap करके आवाज सुनाई देता है, because light is much more faster, 3 lakh meters per second और ये है 344. सवाल ही पैदा नहीं होता है. ठीक है, तो ऐसे भी आपको क्वेश्चन दे सकता है that a man observes a lightning and the distance taken is at what time, and he is at so much distance, at what time does he hear the thunder? He will hear the thunder based on the distance and the time. उसके ऊपर वो thunder को सुने. So you can do those calculations. Always remember, when you're calculating for the hearing, use the speed of sound, and when you're calculating for vision, use the speed of light. ठीक है? Okay. अब आ जाते हैं हमारे last concept में of this chapter, which speaks about ultrasound and applications of ultrasound. Ultrasound. This is a revolution technology. So reflections of ultrasound are actually used in many imaging services. Okay, the first being on health. So what we do, we generate a lot of ultrasounds to the heart, and based on the reflections of the ultrasound, you get electrical signals and you create the pattern of the functioning of the heart. Okay, you can do that for soft tissues. Like normally, if a person's heart is in proper shape and proper functioning, then we will use our ultrasound. से ये सब चीजों में क्या होता है, एक normal चीज को लेंगे and then you will take out their ultrasound signatures. Okay, suppose you will give some ultrasound and you get back. It's very easy for me to say, but very difficult. So the ultrasounds will go and they will come back after reflection and they create a signature that can be converted to electrical signal, and we say, look, if the heart is working properly, this is the ultrasound signature that you should get. And if any signature you are getting which is not in accordance to that particular standard which you have made, एक standard आपने बनाया, then you say there is some problem. This is called electrocardiograph, ECG जो आप करते हैं. In ECG we are using ultrasound itself, but these ultrasounds are not for imaging purpose. ECG was known to us much before ultrasound. Nowadays, have any one of you undergone ultrasound ever? Ultrasound is a technology in which abdomen में अगर किया होगा, so there is a torch-like probe, and that torch-like probe will be moved all around your tummy to check whether your kidney, liver, uterus, ये सब ठीक ठाक है कि नहीं. So that's a probe. You will be made to lie down, and the doctor will be sitting beside you, and some jelly will be put on your particular place, and ऐसे घुमाते रहेगा, and that's an imaging service. Electrocardiograph is not an imaging; it's a graph. आपके शरीर में बहुत सारे प्रोब्स लगा देंगे ऑन योर चेस्ट एंड यू विल बी मेड टू लाई डाउन एंड द प्लॉटर विल स्टार्ट प्लॉटिंग योर अल्ट्रासाउंड सिग्नेचर ECG, और ऐसा एक छोटा सा आपको ग्राफ दे देगा. द डॉक्टर कैन सी द ECG एंड देन अंडरस्टैंड whether there is any anomaly with your heart functioning or not. That has called an electrocardiograph. Now all the tissues that we have in our body, if the tissues are the softness of the tissue, the density of the muscle, कोई tumor form हुआ या नहीं. So ultrasound is ultrasonography, we call it ultrasonography. So you should understand these two things. One is called the echocardiograph. This is ECG, and now what I'm trying to talk to you is about ultrasonography. Ultrasonography मतलब photography जैसा, इसमें आपको imaging होगा. So the ultrasounds will go and their reflections come back, create electrical signals, and based on the reflection of those electrical signals, an image is generated exactly of your organ inside. So that one way you are having to see not exactly like the organ, but yes, the profile can come out. And if anytime, God forbidden, it happens, if you get a chance that an ultrasound is done, you can turn your face and you can actually see your kidney. Not as clear as a kidney, but in some semi-fluid action, आप अपना kidney देख सकते हो. ये ultrasound में होता है. So like that's why ultrasound में you must be studying now in biology. Like there is a ultrasound can also help you detect the gender of the child when the child is in the fetus stage. That's why what do you call, decoding or telling the gender of an unborn child is a punishable offense and criminal offense in India. That technology is known as amniocentesis. जैसे आप अल्ट्रासाउंड रूम में जाएंगे ना, तो वहां पे अल्ट्रासाउंड रूम में usually there will be a lot of pregnancy tests happening. So there will be a poster always. It will be written. You should always know that decoding the gender of the unborn child is a criminal offense. Like people, what used to do, यहाँ पे like people used to pay these doctors, and the doctors used to tell the gender, and if it was a girl, they used to do feticide. As a result, the sex ratio went very bad. Like now in many places in India, like we generally used to have for 1,000 male, used to have say 880 females. Now females have got reduced to 400, 300. लड़की नहीं है. So amniocentesis. Whereas in US and all, it is taken as a charm factor. Like when the lady has conceived or the ultrasound is happening, the doctor will tell what is the gender, so that they know it's a boy or it's a girl, and then they start planning his or her arrival by making socks and this and that. हमारे इंडिया में हमने इसको गलत इस्तेमाल कर लिया है, जो कि नहीं चाहिए. तो this is ultrasonography. The third thing comes is like treatment of calculi का मतलब होता है stones. Okay. Now kidneys में stones develop हो जाते हैं. I am a real time victim of that. So once in your kidney the stones happen, right? So we have got it's called, the process is known as lithoscopy. So there's a lithoscopic probe which will be inserted, and then once the stones are big enough that they cannot get out through the urinary tract, then the stone will cause you problem. Stones are there in everyone's kidney. The problem will happen if your bladder is not full. मतलब आप पानी कम पीते हैं, आपके ब्लैडर में पानी नहीं है. Okay, how do I explain it? Best way. After taking shower, once the bathroom dries, don't you see some part of body here or something gets clogged in that perforated pin? That is the tendency in your stomach also. From your kidneys to urinary bladder में जब आपका urine and that fluid is there, if the stone obstructs that path, that debris which you see on your bathroom, it's same as that stone. When it will obstruct, you will have pain, acute pain. You cannot even think what is that pain. So what is the best way? पानी पीते रहो और स्टोन को फ्लोट कराते रहो. अगर वो स्टोन छोटा साइज में है, then it will get flushed out with your urine. But generally if it is bigger, it will not. Then you have no other way. Either homeopathy, when the stone is very small. In homeopathy there is a plant called Bulbaris vulgaris, and that plant's medicine can actually, it's known as stone crusher. It can crush stone. Otherwise you have to go with ultrasonic treatment, in which through ultrasonic waves they will split that stone into many small fragments, और ये आपके यूरिन के साथ 1-2 weeks में फ्लश आउट होके निकल जाएगा. So people जो oxalate rich food खाते हैं, cashew, spinach, then tomatoes, gooseberry, chocolates, ये बहुत ज्यादा होता है, oxalate, and being a Bengali, like we eat a lot of fish, तो calcium, तो ये stone तो सबको होता है, everybody's bathroom, if the bathroom is wet then you don't see that thing, वो जैसे ही आएगा वो दर्द करेगा. So treatment of calculi. And one more is we use ultrasound is for disinfecting. Now say suppose you have some zones जहां आपका हाथ नहीं पहुंचता है, so what we do, we will actually put them into some solution and then punch ultrasound on that. Ultrasound waves में इतना strength रहता है कि जो भी बैक्टीरिया वगैरह है ये सबको फ्लश करा सकता है. Cleaning is much more efficient. UV cleaning जिसको बोलते हैं ना, ultraviolet होता है, ये ultrasound है. Ultrasound cleaning you will see in many beauty parlors and all these scissors and everything are kept under those UV trays के अंदर में रखते हैं और ultrasound trays में, वो ultraviolet है तो ultrasound में भी ऐसे आप कर सकते हो. But the last thing, I think there's some time. Okay, anyways, we will revise this chapter, but I just wanted to touch that. So one of the things that we use ultrasound for very extensively is in seeing the quality of a structure, a mechanical structure or a civil structure. Say suppose this is concrete, cake जैसा है. Once cake is made, how do you know the cake is made? You put those sticks inside and you see. Cake baking and concrete making is same thing. अब ये जो roof में seepage वगैरह आता है, right? So once this roof is being, the casting of this roof is taking place, I have with my eyes seen casting of Pearl Tower, this tower, everything, and I used to tell my mother, look, it's so raining badly today and they're doing casting. इस floor में जितने लोग flat खरीदेंगे, इसके नीचे जो भी रहेंगे, सब में seepage आएगा. So they use a tool. The concrete will be poured. And once the concrete is poured, there's a tool called vibrator which will vibrate करेगा, मतलब अंदर जाना चाहिए ठीक से. Like when you make a cake batter, you go on and tuck, why? So that no gas bubbles and nothing. Otherwise the cake will not cure properly. जितना भी अच्छा आप करो, तो concrete में ना अंदर में crack रह जाएगा. Cracks or pores will be there. So to detect those cracks or pores also we use, these are called NDT. One way is that NDT, why? NDT in engineering way, NDT means non-destructive test. One test would be इसको तोड़ दो और क्रैक देखो तो ये बर्बाद हो गया. हम नॉन डिस्ट्रक्टिव टेस्ट करेंगे. कैसे नॉन डिस्ट्रक्टिव? और से यू हैव मेड अ कंपोजिट शीट, आपने गाड़ी का डैशबोर्ड बनाया है. हाउ डू यू नो इट इज यूनिफॉर्म ऑल अक्रॉस? सो यहाँ पे हम क्या करेंगे, लेट्स अज्यूम देयर इज अ क्रैक आउट हियर. हाँ, यहाँ पे क्रैक ले लेते हैं, जैसे यहाँ पे क्रैक है. एंड व्हाट यू विल डू, यू विल बी एक्चुअली bombarding this with lot of ultrasound rays. Now if there is no crack, the ultrasound rays will pass through. And there is a receptor out here. So the receptor counts how many ultrasounds आपने भेजे और कितने ultrasound आपको इस तरफ आया. जहां क्रैक होगा ये वापस इस साइड चला. Sonic waves, X-rays also. Ultrasound is one way to do it. UT ultrasound cheaper होता है. जैसे लैब में whenever we do, like my previous role, we used to do a lot of composite structure for defense purpose. Now whether that composite is like baking a bread. Have you seen a slice of bread? Do you see equivalent pores everywhere? No. कहीं पोर बड़ा है कहीं छोटा, वो bread है बेटा. लेकिन जब आप एक composite structure बना रहे हो, then that structure is supposed to resist that temperature. वो जगह तो पहले ही पिघल जाएगा, पट्टू हो जाएगा ना. So how do you do it? ऐसे टक 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 मार के तो नहीं. You need to know what is inside without destroying it. Ultrasound is the easiest way to do it. We call it a UT test. So there will be 4 UT probes out here which will be bombarding ultrasound waves and 4 UT probes this side. चारों तरफ से check होके and it will give you a mapping. Where all cavity is there, पूरा आपको map करके दे देगा, यहाँ cavity है. If that is within your accepted tolerance range, clear this product. If not, UT test used to be our fattu period. Means everything is made. The structure कुछ बनाने दिया है. I can't tell you what is the structure. The structure is all made and the structure looks all good. Now today is our examination. UT होगा. है ज़्यादा देर नहीं, आधा घंटा का टेस्ट. But in आधा घंटा they will tell you whether वो ठीक है कि नहीं है. और अगर नहीं है तो नहीं है. अंदर जैसे ये सब चीज है ना, अभी over the time there might be many internal pores which have got created. Without breaking it, can you get to know? Breaking means destruction. That's called destructive test. UT is NDT. X-rays can also be done. X-ray costly होता है. जैसे आपने पाइपलाइन, 2 पाइप्स को वेल्डिंग किया है, वो वेल्ड एकदम लीक प्रूफ है, कैसे जानोगे आप? अल्ट्रासाउंड सस्ता है, इजी है. एक्सरे थोड़ा सा हैजर्डस हो जाता है. बस That is all about in this chapter. Go through it. If you think that there is something missing, we'll now do. I don't think there's too much of numericals out here. So what it brings us back to is this chapter is more notes oriented. I will share, this is theory oriented. So now start preparing for laws of motion and we go with the first chapter से अब हम papers करना start करेंगे. First we will give numerical oriented papers so that we become strong and we'll do little bit एक level higher problems भी करेंगे motion के. And whenever I'm doing a problem in next class onwards, if there is any relevant theory जैसे यथार्थ which was not with us, okay, now we start our motion problems, we'll cover the relevant theory also. ताकि जब आप ग्रेड 11 में जाओ आपके मन में कोई डाउट नहीं होना चाहिए एक्सेलरेशन क्या है, टाइम क्या है, वेयर टू यूज दिस फॉर्मूला, वेयर नॉट टू डू, बट यू स्टार्ट गेटिंग क्वालिफाइड फॉर द टेस्ट ऑन लॉज ऑफ मोशन. ठीक है, दैट टेस्ट वी विल डू आफ्टर, ये सब त्योहार के बाद ही टेस्ट होगा, मतलब 13 तारीख के बाद, वो भी इन दिनों के बीच में वी विल डिसाइड आवर डेट.